Let's practice working on linear equations together, and specifically when they're written in slope-intercept form. In each of these practice problems, we're going to use the linear equations written in slope-intercept form. We're going to go ahead and identify the slope, identify the y-intercept. We're going to create a 5-point table, and then finally we're going to make a rough sketch so that we can see what this graph looks like on a coordinate plane. Let's check out number 1 here. Number 1, we have y is equal to 2x plus 5. Now what we're going to do here is we're going to identify the slope first, so take a look at this positive 2. This positive 2 is the coefficient for x, and that's always going to represent the slope. So the variable to represent slope is m, so m is equal to 2. Now there's a few ways we can think about this as well. So if the ratio is 2, we can say it's positive 2 over positive 1. We could also say it's negative 2 over negative 1. This is also equal to positive 2. And so any ratio, as long as it equals 2, would represent that slope there. Okay. Now moving on to this positive 5 over here. Positive 5 is going to represent our b value. So b is equal to positive 5. Now, when we identify that b is 5, what we could tell from that is we know what the y-intercept is. So the y-intercept is going to be then located at 0, 5. So whenever you see what b is equal to, you want to identify that that actually tells you a point. It's always going to be 0, b or 0, 5 in this case. And again, this m is equal to 2, and that represents our slope, and this b is equal to 5, which represents our y-intercept, and it gives us this point of 0, 5 on the graph. So we've identified the slope and the y-intercept, so let's go ahead and put a table together and then start to sketch a graph. All right, something I think that is nice to do is we can go ahead and take this y-intercept, or 0, 5, and let's just go ahead and plot that right in the middle of the table. So I'm going to go ahead and put 0, 5 right in the middle of the table, and then we can go ahead and plot that on the y-axis right on the graph. So that's a point that we know is going to be on this graph. Hopefully that makes sense too, though, because if we go ahead and take this 0, if 0 is x, then if we multiply this 2 multiplied by 0, we do get 0, and then 0 plus 5 is 5. So when x is 0, then y would equal 5. Okay. Now in our table, we do have 0 for our first x value, and then we typically just choose numbers skipping by the same distance, going smaller, and then we choose numbers that are going up by that same distance as well. So I'm going to go 1 and 2 below 0, and 1 and 2 above 0. Now if we take this negative 2 and we plug it into this equation, we could find out the y value. So we have y is equal to 2 multiplied by negative 2 plus 5. And 2 times negative 2 is going to be negative 4. Then negative 4 plus 5, that's going to equal positive 1. So when x is negative 2, y is equal to positive 1. So we can go ahead and put that right here. Then we can go ahead and plug in negative 1 into this equation as well. So we can say y is equal to 2 times negative 1 plus 5. 2 times negative 1 is going to be negative 2 plus 5. And negative 2 plus 5 is equal to 3. So when x is negative 1, y is equal to 3. We already have when x is 0. And so let's go ahead and try when x is equal to 1. We can go ahead and plug that in right here. So that's going to be y is equal to 2 times 1 plus 5. 2 times 1 is 2 plus 5, and 2 plus 5 is equal to 7. So this is going to be a 7 here. Finally, now x is equal to 2, so if we plug 2 in here, that's y is equal to 2 times 2 plus 5. 2 times 2 is going to be 4, so we have 4 plus 5, and that's equal to 9. So right over here, we can put a 9 in our table. Okay, so let's go ahead and plot each of these points. So negative 2, 1, so that's 2 to the left, and then 1 up. So I'm going to go ahead and plot that point at negative 2, positive 1. Then for this next point is negative 1, 3. So let's go ahead and go 1 to the left, and let's go up 3 units and plot that one down. That's going to be right over here. And then we already have the 0, 5, that one's done. And then let's do 1, 7. So that's going to be 1 to the right, and let's go 7 up. That'll be right in this location in quadrant 1. And then finally we have 2, 9. So let's go 2 to the right, and then that's 2 to the right. Let's move up 9 units, that's right up here. And so this is going to be the point. Okay, so we should see that these points all create this perfectly straight line. So let's go ahead and try to connect those the best we can. And go ahead and do that, and then draw this line up here. And so we can see that this is going to be a straight line for our equation. making sure we do understand what the slope represents of positive 2 to positive 1. Here we're moving plus 2, then plus 1 to the right, plus 2 is up 2, right, plus 1 is to the right 1. So you can see we create these steps here of plus 2 plus 1, plus 2 plus 1. If we take a look at using the negative 2 and negative 1, that's moving from the top down. That's minus 2 or down 2, and then to the left 1. So minus 2 to the left 1, down 2 to the left 1. And so we do end up at each dot. It just depends on which direction you're going in for your steps. For number 2, we have this equation of y is equal to negative 3x plus 8. So right from the beginning, we do like how y is isolated. Let's look at the coefficient for x. It looks like it is negative 3. So from that, we're going to go ahead and say that m is equal to negative 3. That's the slope. And there's two ways we can really think about this. We could think about this as negative 3 over a positive 1, or we can think about this as a positive 3 over negative 1. Either way is okay because we're going to get a negative value despite where we put the negative and the positive. Now this 8 over here, this positive 8, that lets us know what our b is. So we can go ahead and say that b is equal to positive 8. And if we know that, then we know the point right away of 0, 8 we can put on our graph. So this right here is our slope that tells us our rate of change. This is the up and down, and this is the left and right. This is the up and down, and this is the left and right. Also, we found out that b is equal to 8, and that always tells us a point that's on our graph of where the graph crosses the y-axis. Now for the table and the graph. So let's go ahead and take this first point we created and let's put that right in the middle of our table. So I'm going to go ahead and put 0, 8. Okay, and then we're going to go ahead and try some numbers that are smaller. Let's do negative 1 and negative 2, and we'll try to fit as many of these as we can on here. And then let's go to positive 1 and positive 2. All right, so again, you can just create those x values, whatever you want, but these are pretty easy numbers to use, I think, just because they're in order and they're going up by 1. Then we're going to use this negative 2, and let's plug it into the equation to figure out what y is. So if we say y is equal to negative 3 multiplied by negative 2 plus 8, negative 3 times negative 2 is positive 6. So we have 6 plus 8, and that's going to equal 14. All right, so when x is negative 2, y will equal 14. Moving on to this next one, if x is negative 1, we can plug that in right over here. So that'll be y is equal to negative 3 multiplied by negative 1 plus 8. Negative 3 times negative 1 is positive 3. Positive 3 plus 8, that's equal to 11. So when x is negative 1, y is equal to 11. So we can go ahead and put that in our table. We already took care of the 0, 8. Let's move on to x equaling 1. So let's go ahead and plug that in. So y is equal to negative 3 times 1 plus 8. Negative 3 times 1 is negative 3. Negative 3 plus 8 is equal to positive 5. So let's go ahead and say we know this is going to equal 5. And then finally, when x is 2, let's see what happens. So we have y is equal to negative 3 times 2, and then add 8. And then negative 3 times 2 is going to be negative 6. Negative 6 plus 8 is equal to positive 2. So let's put a positive 2 for that last one. All right, for this 0, 8, we can plot this one right away. That's going to be on the y-axis. As we've kind of mentioned, that's what b represents. It's that dot that's going to go on the y-axis somewhere. Okay. Now, what we're going to do is I'm actually going to leave this one out, this negative 2, 14, just because it's not big enough. We could scale the graph down and make every box worth 2, but I'm just going to go ahead and leave it out for now. I'm also going to leave this one out for now just because it's not going to fit. So I'm going to just keep everything scaled the same here. And then we have this 0, 8, and let's go on to try to plot this 1, 5. So 1, 5 is going to be 1 to the right and then up 5. 1, 2, 3, 4, 5, something like right here. And then if we plot this 2, 2, that's 2 to the right and then 2 up, and that would be right here. Okay, so again, I realized that I didn't put all 5 dots, but right now I'm just putting 3 of them. The other ones are just past where my graph allows, and I just wasn't going to scale this on here, and hopefully that is okay. So I'm just going to go ahead and put arrows on here, and hopefully you realize that if you keep going in this direction, you will eventually hit this negative 111 and negative 214. Okay, so this would be the graph for this linear equation. For number 3, let's see, we have this y is equal to negative x minus 3. So let's be careful about knowing what's going on here. So when you see this negative x, it tells us right away that there's a -1 that's invisible there. So m is equal to -1. And so you can either think about this as -1 over +1, or you can think about this as +1 over -1. So remember, whenever the slope is negative, or you have a coefficient for x that's negative, either the rise or the run, either one of those has to be negative and the other one has to be positive. Okay. Moving on to this -3. This -3 just lets us know that our b value, the b value is -3, or our y-intercept is -3. So we know there's a point of 0, -3 on the graph. Okay, so if we go ahead, now that we have our slope, which is -1, and we know our y-intercept equals -3, we can go ahead and make a table and a graph together. Alrighty, right away we'll take the 0, -3, and let's plot that right in the middle of our table. So go 0, -3, and we can go two numbers smaller, so let's go -1 and -2, just like in the last few examples, and we'll go to +1, +2, and let's figure out what the y values are so that we can go ahead and plot some points down. So let's take this -2 and plug it in here. So that'll be y is equal to -2 minus 3. Now -2 is +2, and +2 take away 3 is -1. So when x is -2, y is equal to -1. So we can go ahead and write that value in. Now x is -1, so let's plug that in here. We're going to have y is equal to -1 minus 3. A -1 is just a +1. +1 minus +3 is going to be -2. So let's go ahead and put -2. We already have our y-intercept, that's that 0, -3. If we take x equals 1 and plug it in here, that's going to be y is equal to -1, take away 3. A -1 is just -1, take away 3. That's the same thing as -1 plus -3, which is -4. So that's going to be this y value for that x. And then finally, when x is 2, we can plug that in. So we're going to have y is equal to -2 minus 3. Now a -2 is just -2, take away 3. -2 minus 3 is the same thing as -2 plus -3, which is -5. So when x is +2, y is equal to -5. Alrighty, so let's go ahead and plot some points here. So 0, -3, I'm going to plot that on the y-axis. Again, that b value is very helpful to give us somewhere to start from. And let's go ahead and plot this -2, -1. That's going to be in quadrant 3, so it's 2 to the left and 1 down from the origin, right over here. Then for this -1, -2, that's going to be in quadrant 3 again. That's 1 to the left and 2 down, right over here. Then this 1, -4, that's going to be in quadrant 4. That's 1 to the right and then 4 down. That's going to be down here. And finally, 2, -5 is going to be also in quadrant 4. That's 2 to the right and then 5 units down. So these are all of our points. We can go ahead and make a line to connect them all. So something like this. I'm just going to go ahead and make this a little longer so we can see the continuation, and it goes in both directions forever. And so that would be the graph for this. Okay. I think I forgot to write this earlier, but if you take a look at this one, I'll show you right over here that this is basically saying this -1 on top is saying let's go down 1, and the +1 is saying go to the right 1. So -1, +1, -1, +1, -1, +1. And if you wanted to use this ratio, that's going from this dot at the bottom up. So it's +1, but then left 1 for the -1. So +1, -1, +1, -1, +1, -1. So the rise and the run just tell you the steps. Okay, so I think going back to 4, so going back to actually number 2 here, when we took a look at this -3 and +1, that's like saying going down 1, down 2, down 3. So that's the -3 and then +1, -3, and then +1. Using the other ratio, that's saying +3, so it's going up 1, 2, 3, then to the left 1, going up 1, 2, 3, and then to the left 1. So 2 different ways of getting to each of the dots depending on which direction you're going. For number 4, we have this equation y is equal to 4x minus 7. So this 4 tells us the slope, so we can say that m is equal to 4. But thinking about that as a ratio, that can either be a +4 and +1, or we can say that's going to be a -4 and a -1. Either way, we get a +4 for the slope. Now for this -7 is going to be b. b is equal to -7, and that tells us our y-intercept. Our y-intercept is going to be 0, negative 7. So we know our slope, which is 4, we know our y-intercept, which is going to be negative 7, and let's go ahead and make a table and then a graph together. We'll take this 0, negative 7 and put that in the middle of our table like we have in the past few examples. So we can start with that, and we can also plot that if you want to right away, or you can wait a little bit, totally up to you, but I'm just going to put a dot so we have something going here. And I'm just going to go down to negative 1 and negative 2 and go up to positive 1, positive 2, and just start plugging in our x values. So for negative 2, we plug that in here. That's going to be y is equal to 4 times negative 2 minus 7. Now 4 times negative 2 is negative 8. Negative 8 take away 7. That's the same thing as negative 8 plus negative 7, which is negative 15. So that's not going to fit on our graph, but we know it would be there if we had a bigger graph, or if we scaled it, which I'm not going to do, sorry. We could do it in another video maybe. So there's negative 1, plug it in here, so that's going to be y is equal to 4 times negative 1, take away 7. 4 times negative 1 is negative 4, take away 7, so that's negative 4 plus negative 7, which is negative 11. So let's go ahead and put that in our table. That one also won't fit on our graph, that's okay. Then moving down to when x is 1, plug that in. So we have y is equal to 4 times 1, take away 7. 4 times 1 is 4, take away 7. 4 minus 7 is negative 3. So let's put negative 3 in here. And then finally, what happens when x is 2? So if x is 2, we have y is equal to 4 times 2, take away 7. 4 times 2 is 8. 8 take away 7 is 1. So let's go ahead and plot that one as well. So I think I can't plot this one. Won't fit. This one won't fit. This one we already did. For 1, negative 3, that's in quadrant 4. So 1 to the right of the origin, then down 3 units. And then finally, 2, 1, that's going to be in quadrant 1. That's going to be 2 units to the right and then 1 unit up. So right over here. Now, since we couldn't put those other points, you can notice there's a pattern here of going up 4 to the right 1 and up 4 and to the right 1. So if we continue that pattern of up 4 to the right 1, we could plot more points even though they weren't on our graph. We could plot them and show that these would be if we made a longer table or we made more points in this direction, just because we know the slope here is up 4 and to the right 1. Okay, so if we go to connect these, you can notice they're all going to be on the same straight line, which is nice because that is what makes linear equations linear. We have a constant rate of change. I'll throw some arrows on there, and that would be our graph. Our slope of plus 4 over plus 1. Here is the plus 4 or 4 up. Here's the plus 1. Here's the plus 4. Here's the plus 1. Here's the plus 4. Here's the plus 1. Again, positive means up and positive means to the right, so that's what all of these are. And if you were going using this other direction of negative 4 over negative 1, that would be this here of going negative 4, negative 1, negative 4, negative 1, negative 4, negative 1, and finally negative 4, negative 4, negative 1. So either way you go, you're going to get a dot on this graph. Number 5. For number 5, we have this equation of y is equal to 1/2 x minus 6. So we have a fractional ratio here, or fractional slope. So here we can see that m is equal to 1 over 2. So we can either think about that as a positive 1 over a positive 2, or we can think about that as a negative 1 or a negative 2. And then for our y-intercept, we can say here that b is equal to negative 6. And so we know the point on the graph is going to be 0, negative 6. Okay, so we have that information. Let's go ahead and make a table and a graph together. Let's go ahead and take this y-intercept of 0, negative 6 and plot that right in the middle. So put 0, negative 6. Now you could go ahead and use negative 1, negative 2, positive 1, positive 2 to fill in each of these x values. But notice how we have a fractional slope here and the denominator is equal to 2. So we like things to cross cancel. So I'm going to go ahead and use multiples of 2 because I know that's going to be easier. So let's use negative 4, negative 2, and then positive 2, positive 4. So jumping by 2's the whole way. Okay. Now if we go ahead and use negative 4 and we plug that in here, that's going to show us y is equal to 1/2 times negative 4. That's the same thing as negative 4 over 1, and then take away 6, right? Now this 2 and negative 4 are going to cross cancel, and that's going to become a 1, that's going to be a negative 2. So you're going to get negative 2 over 1, or just negative 2 take away 6. and negative 2 minus 6 is just going to equal negative 8. All right, so again, I chose specifically to use negative 4 because it would cross cancel with the 2. And so we know that negative 8 would be the y value when x is negative 4. Now if we use this negative 2 now and plug it in, that's going to be y is equal to 1/2, and we're going to multiply that by negative 2 over 1, and then take away 6. Now these two 2's are going to cross cancel, and so we're going to end up with negative 1 take away 6, which is equal to negative 7. So I'm going to go ahead and write negative 7 here. Following that, let's take this positive 2 and plug it in. Same idea, just no negative, so y is equal to 1/2 times 2, which is 2 over 1, and then take away 6. These 2's are going to cross cancel to make 1, so we have 1 minus 6, and that's equal to negative 5. Let's go ahead and put that negative 5 right over here. And then finally, let's take this 4 and plug that in. So we're going to have y is equal to half of 4, take away 6. Half of 4, these cross cancels, and you just get 2. Half of 4 is 2. 2 minus 6 is equal to negative 4. So let's go ahead and put negative 4 here. Plotting the 0, negative 6, that's going to go 1, 2, 3, 4, 5, 6 in the negative y direction. Okay. This negative 4, negative 8, if we go ahead and plot it, that's going to be in quadrant 3. So 4 to the left, 8 down. I think right here looks about right. And then we have negative 2, comma 7. That's also in quadrant 3. That's 2 to the left, then 7 down. So I think something like here. Finally, not finally, but next we have 2, comma negative 5. So 2 to the right, and then 5 units down. That looks just about right. And finally 4, negative 4, that's going to be 4 to the right, and then 4 down. So I think it's going to go right here. These dots do look like they are in a nice straight line, so we're going to connect them, and we can see the progression of this little constant rate of change. And if we look at the slope here, this positive 1 over positive 2, here's the positive 1, here's the positive 2, positive 1, positive 2, positive 1, positive 2, so on and so forth. So that's the first one. But if you want to look the other way, here's the negative 1, negative 2, down 1, left 2, down is negative, left is negative, down is negative, and left is negative. So two different ways of writing the steps, but you still get the same points. Here's number 6. For number 6, we have y is equal to 1/3 x plus 4. So the slope here is going to be 1/3, or m is equal to 1 over 3. We can think about that as a positive 1 over positive 3, or we can think about it as a negative 1 or a negative 3. Okay. Moving over to this plus 4, that means that b is equal to positive 4 here, or just a 4. And that means we know there's a point on the graph of 0, comma 4. All right, so we know our slope, we know our y-intercept. Let's go ahead and make a table and then a graph together. So we like knowing what b is because that gives us a free point. Let's go ahead and plot that in over here. So that's going to be 0, comma 4. And I'm actually going to go ahead and just put it on the graph just so we have a reference point of where to begin. And let's go ahead and see here. You can also just go ahead and use the slopes. I'm actually going to show you this in the last couple examples here. So we could also use the slope and go +1, +3. So I'm actually going to go +1, which is up 1, and then to the right 3. So you can go +1 and then +3. You can actually just do that over and over again. And so I'm going to plot these now, and then we'll verify using the algebra as well. Or you can also use this -1 over -3 and go down 1 and to the left 3. And that's also going to be a quicker way of getting more dots on your graphs as well. So let's go ahead and verify this using our algebra, but this is graphically why you would want to know the slope ratios and the y-intercept. Okay. Now, going ahead and choosing for these x values over here, I'm going to go ahead and use multiples of 3 just because we have a denominator of 3 and I want things to cross cancel. So I'm going to use -3, -6, and skip count by 3's here. Okay. Let's see what happens if we take this -6 and we plug it in. That's going to be y is equal to 1/3 of -6, which is -6 over 1. So 1/3 of 6 should be 2. So if you cross cancel these, you do get -2. So you get -2 plus 4. -2 plus 4 is equal to 2. So when x is -6, y is equal to +2, which makes sense with this dot. It's already plotted. And so that checks out. What happens now when x is equal to -3? If we plug in -3 here, we'll get y is equal to 1/3 times -3, so it's -3. Now what happens when x is -3? If we plug that in, we're going to get y is equal to 1/3 of -3, -3/1, and then plus 4. These 3's will cross cancel, you're left with -1, so y is equal to -1 plus 4. -1 plus 4 is equal to 3. So when x is -3, y is +3, and that's actually this point right here, which we've already verified, so that is good to go. We've already done 0, 4, that's located here. Now when x is 3, let's go ahead and plug this in. Okay, y is equal to 1/3 of 3, which is 3/1. These 3's are going to cross cancel as we planned earlier. Now we're just left with 1 plus 4, and that's equal to 5. So when x is 3, y is equal to 5, and that's this point right over here. So we can go ahead and plot that, and then write the 5 in here. And finally, what happens when x is 6? Plug that in, we're going to get y is equal to 1/3 of 6. Now 1/3 of 6 should just be 2, but if we cross cancel, that verifies it's 2. So we get 2 plus 4, and 2 plus 4 is equal to 6. So when x is 6, y is 6, and that's actually this point right here. So we can go ahead and put this 6, and I think we have everything that we need here, right? All we have to do is maybe just go ahead and connect these dots, and you can see that we do get a perfectly straight line. And if you look at the ratios here, this +1, +3, here's the +1, here's the +3, +1, +3, +1, +3, so on and so forth, this constant ratio. And for the -1, -3, that's down 1, left 3, down 1, left 3, down 1, left 3, so on and so forth. So different ways of looking at it, and here's our graph. Here's number 7. We have y is equal to 2/3 x minus 5. So our slope here is going to be 2/3, so m is equal to 2/3. That can be considered as a +2 over +3, or a -2 over -3. And then for this -5 here, we can say that b is equal to -5, which gives us the point right away of 0, -5. Let's go ahead and set up a table and then a graph. This 0, -5 we can plot right away. We'll put the 0 in the middle and the -5. Now because our slope has a denominator of 3, let's go ahead and just use multiples of 3 for our x values, so -3, -6, and we could also use +3, +6 just to keep things consistent. Plotting this 0, -5, we can go ahead and put that right on the negative y-axis right from the beginning. And if we go ahead and use the slope, we can use the 2/3, the +2 and +3, and move from the y-intercept. So we can just start from that purple dot and move +2 up and then +3 to the right. So let's see, if we go ahead and move up 2 and then to the right 3, that would be right over here. And if we keep going up 2 and to the right 3, we can basically keep plotting more dots, more than we have on our table, right? Or you can go ahead and use the other ratio of down 2 and to the left 3, and that'll also work. So down 2, left 3, down 2, left 3, and you can see that there's a continuation of this line here, right? Now let's check algebraically just to make sure. So this -6, if we plug it in here, that's going to be y is equal to 2/3 multiplied by -6/1, and then take away 5. And then 3 and -6, that's 1 and -2 if we cross cancel. 2 times -2 is -4, and -4 take away 5, that's going to be -9. So when x is -6, y should be -9. And you can actually see that located right down here. That's -6, -9. So let's go ahead and put that in our table. That's good to go. And what about when x is -3? If we plug that in here, that's going to be y is equal to 2/3 multiplied by -3/1, and then take away 5. These 3's will cross cancel, so you get -1. 2 times -1 is -2, take away 5, and that'll be -7. So -3, -7 is plotted right over here. So we can plot -3, -7, or put that in the table because we've already plotted it. This one, again, is taken care of. We always are given that by the b value, which is nice. Then let's go ahead and take this 3 and plug it in. So that's going to be y is equal to 2/3 of 3. 2/3 of 3 and then take away 5. Now the 3's will cross cancel, make 1's. 2 times 1 is 2, so we have 2 minus 5, and that's equal to -3. So we have 3 comma -3, which is in quadrant 4 over here. Let's put that in the table just so we have it. And then finally, we have this 6. Let's plug in 6, so it's y is equal to 2/3 multiplied by 6, which is 6 over 1, take away 5. This 3 and 6 will cross cancel, make 1 and 2. 2 times 2 is 4, so 4 minus 5 is going to equal -1. Cool, so right over here, and so 6 comma -1, this final point is actually located in this spot here. So all these points do check out. So you can make the table first, then plot the points, or you can just use the slope and get those points if you don't need a table. That's honestly a little faster, but I'm just showing you both so you can see maybe the pros and cons or the similarities or how they're connected. All right, so there's our graph for number 7, and here's one more, number 8. Oh wait, let me go back real quick just to show the steps, right? So for this +2, +3, that's +2, that's +3, +2, +3, +2, +3, +2, and +3. And this one's the -2, -3. So -2, -3, down 2, left 3, down 2, left 3, down 2, and left 3. So there's our steps, okay? Finally, for number 8, we have y is equal to 4/3 x minus 3. And so the slope here is going to say, we know it is rising 4 and running 3. So we can say +4 and +3. Or we can say this is falling 4 and moving to the left 3. No matter how you want to look at it, we're going to get the same slope. And this -3 means b is equal to -3. Or the point we know right from the beginning is 0, -3. That's our y-intercept. Now let's go ahead and look at the table and the graph. From the 0, -3, let's go ahead as we've done and put that in the middle of our table. So 0, -3, and let's go ahead and see we have a denominator of 3 in our slope, so let's go ahead and skip count by multiples of 3 so that everything will cross cancel nicely. And then so finally we can go ahead and plot this 0, -3 along the y-axis for this final one. And let's go ahead and use a slope again here. So it's going to be up 4 and then to the right 3. So if we go up 4 and to the right 3, we could plot this one right over here. We go up 4 and then to the right 3 again. That'll be here. Up 4 and then to the right 3. We can go from this purple dot and move down 4 and then to the left 3, and we could plot a point here too. And I'm going to run out of space. So here are some examples of some points that'll be on this graph as well. But let's go ahead and do the algebra to confirm. So this -6, we plug it in here. Y is equal to 4 over 3 multiplied by -6 over 1, take away 3. This 3 and 6 will cross cancel to make 1 and -2. 4 times -2 is -8. -8 take away 3 is -11. So when x is -6, y is -11, and that technically doesn't fit on our graph, but it'll be there if you make a bigger graph. When x is -3, plug that in over here. So we have y is equal to 4 over 3 multiplied by -3 over 1, take away 3. These 3's cross cancel. You get -1 and 1. 4 times -1 is -4. -4 take away 3 is -7. So when x is -3, y is -7. And that's actually this dot we've already created. So let's go ahead and just put that in the table. We already have 0, -3 that we took care of. That was our freebie. And then what about when x is 3? When x is 3, we can say y is equal to 4 over 3 multiplied by 3 over 1, take away 3. These 3's cross cancel to make 1's. 4 times 1 is 4. 4 take away 3 is equal to 1. Okay, so when x is equal to 3, then y is equal to +1, and that's this dot here. And we can put that in our table. Finally, when x is 6, plug that in here. We have y is equal to 4 over 3 times 6 over 1, take away 3. This is 1, that is 2. 4 times 2 is 8. 8 take away 3 is equal to 5. So when x is 6, y is equal to 5, and that's this point over here on the graph in quadrant 1. And so we can go ahead and fill our table in. So we have a bunch of these values that do check out with our dots we already put by just looking at the slope and the y-intercept. And let's go ahead and see. I can hopefully make this work. It's kind of off a little bit, huh? That's better. And I'm gonna go ahead and just put some arrows. And so there's our graph. And if we look at the steps of +4, +3, here's the +4, here's the +3, here's the +4, here's the +3, here's the +4, and here's the +3. And if we're gonna use the negative versions, notice how you can still get the same thing, just going down and to the left as opposed to going up to the right. So there you have 8 different practice problems on graphing linear equations, making their tables, figuring out their slope and their y-intercept, all from just being given a linear equation that's written in this slope-intercept form, which is just this y equals mx+ b form. Okay, so hopefully you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.